Hello. We will now continue with the second part of lesson 3.1 by discussing Coulomb's law. Now, Coulomb's law is a quantitative description of how electric charges interact with one another. In other words, when one electric charge is kept near another electric charge, what kind of force exists between them? Now, before I go into the description of Coulomb's law, I would like to review with you maybe a couple of minutes on the adding of vectors. I hope you remember from Physics 1, if you have vectors, how do we add them? Now, force between two electric charges is a vector quantity. So, if you have two or more forces acting on a particular charge due to different charges, how do we find the net force or the resultant force? Alright, so give me a second. Let me review that with you. Suppose you have a vector of length 15 Newton making an angle of 37 degrees with the x-axis. Now, how do we break this vector into a horizontal component and a vertical component? I hope you remember the concept we discussed in Physics 1. We used the concept of unit vectors. Do you remember that a vector of one unit along the x-axis is called I, and a unit vector in the y direction is called j? Therefore, what are the components of this vector? 15 Newton at an angle 37 degrees. We will write this vector as, suppose this vector is A. I will write it as A equal to 15 cos 37 degrees I plus 15 sine 37 degrees j. This is the x component, the component horizontally, and this is the y component. In other words, the 15 cos 37 is this component, that is 15 cos 37. And this is the y component, that is 15 sine 37 degrees. In the same way, if I have a vector that way, suppose I have a vector of 20 Newton at an angle of 215 degrees. How do I write the component form of that? Suppose this vector is B. I will write B equal to 20 cos 215 degrees I plus 20 sine 215 degrees j. In other words, you have this is now the x component and this is your y component. Now you must be very familiar with how to add vectors like this, because this is the only way we can add forces acting on an electric charge. Alright, in that case, let's go and discuss Coulomb's law. What does Coulomb's law deal with? Coulomb's law gives us a quantitative description of the force on one point charge due to another point charge separated by a distance. And this is the description of Coulomb's law. I want you to read this and write it as a mathematical expression. Alright, I'm going to read it for you. The force between two point charges varies directly as the product of the two charges and inversely as the square of the distance between their centers. Alright, can you write a mathematical expression for that? It will look like this. the force between two charges is directly proportional to the product of the two charges. If I call the two charges as Q1 and Q2, and if they are separated by a distance r, this is the mathematical statement of this description. The force between 2 point charges Q1 and Q2 separated by a distance r is F is proportional to Q1 Q2 over r squared. And as usual, what will we do? We will replace this proportionality sign by an equal sign. Alright, let's go and do that. So this is our situation. A charge Q1 is separated from a charge Q2 by a distance r. The force F between the two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. Alright, now if charge Q1 is separated from a charge Q2 by a distance r, then that equation becomes F equal to, you remember, the proportionality sign has been replaced by the equal sign by adding a constant k. So F equal to k Q1 Q2 over r squared, and that is the mathematical statement of Coulomb's law. Once you know this, we can solve problems using that concept. Well, this gives you the magnitude of the force. Remember, force is a vector quantity. How do we obtain the direction? The direction of this force is obtained by measuring the angle this force makes with the positive x-axis. The direction of a vector is always measured as the angle the vector makes with the positive x-axis. Alright, if you are not quite thorough with it, I want you to go back and look at vectors we discussed in Physics 1. Here, k is a constant of proportionality, and it has an approximate value of 9 times 10 to the 9 Newton per meter squared per Coulomb squared. The unit of k is Newton meter squared per Coulomb squared. Now this value is worth remembering. The value of this constant k is 9 times 10 to the power of 9 Newton meter squared per Coulomb squared. Alright. Now k can also be written in terms of another constant. Look at this. K equal to 1 over 4 pi epsilon naught. Now this epsilon naught is another constant, and we call it the permittivity of free space. What does permittivity mean? In order that one electric charge may exert force on another electric charge, this force is conveyed through a medium. And so epsilon naught is a property of that medium in which the forces are being conveyed. And so epsilon naught is called the permittivity of the medium where these charges are separated. So epsilon naught is called the permittivity of free space. Well, assuming that these charges are placed in free space, epsilon naught is the permittivity of free space. And it has a value 8.84 times 10 to the power of negative 12 Coulomb squared per Newton per meter squared. I want you to remember that form of k. K equal to 1 over 4 pi epsilon naught, where epsilon naught is called the permittivity of free space, and it has this value. And therefore, we can now write the Coulomb's law equation. Replace this k by 1 over 4 pi epsilon naught. F equal to 1 over 4 pi epsilon naught Q1 Q2 over R squared. As I told you, this gives you only the magnitude of the force. Now we also need the direction. The direction is always obtained by measuring the angle the resultant force vector makes with the x-axis. Determining the direction of electric force vector. Well, if a negative charge is separated by a negative charge, look at this. What is the direction of force on this charge on the left by the charge on the right? It is directed away from it. Is that right? The force on charge A by charge B is directed away from charge B. In the same way, the force on charge B by charge A is directed away from it. So the force between two like charges are directed away from each other. Now similarly, what is the force on charge C by charge D? They are unlike charges, therefore the force is an attractive force, so the force on C is directed towards D. Similarly, the force on D is directed towards C. So we will use this concept in order to mark the direction of the force. That means we not only need the magnitude of the force, we also need the direction of the force. Let's do a small problem. 3 point charges are on the x-axis. Q1 equal to negative 6 microcoulomb at x equal to negative 3 meter. Q2 equal to 4 microcoulomb at the origin. And Q3 equal to negative 6 microcoulomb at x equal to 8 meter. Find the force on Q3. So, you have 3 charges, Q1, Q2, Q3. You need to find the net force on Q3. Remember, Q3 experiences a force due to Q1. It also experiences a force due to Q2. The net force is therefore the vector sum. Alright, how do we go? Make a mental picture. Now here is the picture of what is happening. You have a charge Q1 equal to negative 6 microcoulomb at x equal to negative 3. You have a charge Q2 equal to 4 microcoulomb at the origin. You have a charge Q3 equal to negative 6 microcoulomb at x equal to 8 meter. We need to find the force on this Q3 due to both these charges. Now, what do? We find each of these forces. First, we find the force on Q3 by Q1. Then we find the force on Q3 by Q2. Then add the two forces together using the method of vector addition. Alright, we will use the notation. I want you to watch this. F31 for the force on Q3 by Q1. So F31 means force on charge 3 by charge 1. What does F32 then means? F32 is the force on Q3 by Q2. Similarly, R13 is the distance of Q1 and Q3. The distance of Q1 and Q3 is R13. And R23 is the distance of Q2 from Q3. So, we are going to use these notations in the equation that we had earlier. Alright. What is R13 equal to? What does R13 stands for? The distance of Q1 from Q3. You can see Q3 is at x equal to 8. Q1 is at x equal to negative 3. Therefore, the distance from Q1 to Q3 is 8 plus 3, 11 meter. Alright, what is R23? The distance of Q2 from Q3 is 8 meter. That's no problem. F31, force on 3 due to 1. Force on Q3 due to Q1 is K Q1 Q3 over R13 squared. The direct formula of Coulomb's law. Alright, we know all these values. K is 9 times 10 to the 9. Q1 is 6 microcoulomb. Now remember, when you are using this formula, we are only calculating the magnitude. So I have dropped that negative sign. Only use the magnitude or the numbers so that we get a measure of the force. The direction of the force we will find later. So Q1, the magnitude of Q1 is 6 microcoulomb. Write it as 6 times 10 to the negative 6 coulombs. That's the proper unit. And Q2 is Q3 is also negative 6 microcoulomb. I use only the positive value. 6 times 10 to the negative 6 divided by the distance between them is 11 meter. And that gives me 0.0027 Newton I. Now, why did I call it an I vector? Now remember, an I vector is a vector along the x-axis. Now, what is the direction of the force on Q3 by Q1? Q1 is a negative charge, Q3 also is a negative charge. Therefore, the force on Q3 by Q1 will be directed away from Q1. So it will be along the positive x-axis. And so I used I. So that means the force on Q3 by Q1 is 0.0027 Newton in the positive x direction. This is the positive x direction because it is a repulsive force. So that is the force F31 equal to 0.0027 Newton. Okay, let's now find the force on Q3 by Q2. Alright, F32, force on Q3 by Q2. Again, is K times Q2 Q3 divided by R23 squared. Put all the values. K is 9 times 10 to the 9. Q2 is 4 microcoulomb, 4 times 10 to the negative 6. Remember, the units have to be always charged in coulomb. So microcoulomb has to be converted to coulomb. And Q3 is 6 times 10 to the negative 6 divided by 8 squared, the distance between them. And that is negative. Now, how did I know that now the force is negative? I said it is negative 0.0034 Newton. Where did that negative come from? Well, it comes from our understanding of the interaction between the charges. Q2 is a positive charge. Q3 is a negative charge. Therefore, the force on Q3 by Q2 will be an attractive force directed towards Q2. It is directed in the negative x direction. Look at that. It is directed in the negative x direction, and that is negative 0.0034 Newton. And now, the two forces on Q3, one is a positive x force, the other is a negative x force. It is not difficult to add them. So, therefore, the net force on Q3 is 0.0027 Newton I minus 0.0034 Newton I. Since they are both x forces, we can simply add them. gives me negative 7 times 10 to the negative 4 Newton I. So the net force on Q3 by these two charges is a force directed in the negative x direction, and its magnitude equal to this. Alright? That's a very simple way of doing that problem. Let's go and do another one. So, in calculating the force between electric charges, we use the absolute value of the charges. You saw what I did there. I did not use the sign of the charges. We used the absolute value of the charges and assign the direction of the force depending on whether the force is an attractive force or a repulsive force. The force between Q1 and Q3, because they are both negative, it's a repulsive force. The force between Q2 and Q3 is an attractive force. Another problem. A charge Q1 equal to 5 microcoulomb is on the y-axis at y equal to 3 meter, and another charge Q2 equal to negative 5 microcoulomb is at y equal to negative 3 meter. Find the force on a charge Q3 equal to 2 microcoulomb located at x equal to 8 meter. Now what I would like you to do is pause this video and draw a diagram of this. Make a picture of this. If you are not able to make a picture, you cannot do this problem. And then come back and watch my step. Alright, now here is the picture. A charge Q1 equal to 5 microcoulomb is at y equal to 3. And a charge Q2 equal to negative 5 microcoulomb is at y equal to negative 3. A charge Q3 equal to 2 microcoulomb is at x equal to 8 meter. You need to find the force on this charge due to these two. Well, our first task is to find the distance between these. Now look at the way I have written here, R13. What does R13 stands for? R13 is the distance between the charges 1 and 3 in this. And you know, here we have a right triangle where this leg is 8 meter and that is 3 meter. Therefore, the square of the hypotenuse, R13 squared, is 8 squared plus 3 squared equal to 73. Now, in our equation, we will need the value of R13 squared. The value is 73. Similarly, the square of the distance R23, R23 squared also is 73. Is that right? The square of that distance is 8 squared plus 3 squared. Okay, once you know these distances, there you got R13 squared is 73, R23 squared is also 73. I hope you understand why or how we got those numbers. Okay, F31, what does F31 stands for? Force on Q3 by Q1. Force on Q3 by Q1 is K Q1 Q3 over R13 squared. We have all those values, so that will be 9 times 10 to the 9 times 5 times 10 to the negative 6. 5 microcoulomb is Q1. And Q3 is also 5 microcoulomb. No, Q3 is 2 microcoulomb, so that will be 2 times 10 to the negative 6. Divided by R13 squared is 73. What is that equal to? Always, please do not take my value. Always do that on the calculator. Make sure that you get it. And if you don't get that, maybe I'm wrong or you are wrong. So you've got to check it again. And if you have questions, get back to me. Alright, Now tell me, we now got the magnitude of the force on Q3 by Q1. What is the direction of this force? Well, Q3 is positive, Q1 also is positive, therefore like charges repel. That means Q3 will be repelled by Q1, so this force is directed away from Q1. And so F31 is a force directed away from Q1. That will be the direction. Alright, let's go to the next slide. We found F31, we now have to find F32. F32 equal to K Q2 Q3 over R2 3 squared. And you can see all those values are the same actually. That means it will give you the same answer for F32 and F31 have the same magnitude. That's again 0.0012 Newton. That is the magnitude of the force on Q3 by Q2. What is the direction of that force? Anybody tell me? What is the direction of the force on Q3 by Q2? If you remember, Q2 is a negative charge and Q3 is a positive charge. So the force on Q3 by Q2 will be a force of attraction. The force will be directed towards Q2. This is an attractive force and so is directed like this. That will be F32. Now, what we need is we got to add these two vectors. How do we add these two vectors? Well, in order to add two vectors, you got to break them into their x component and y component. Now, can you write this vector into its x component and y component? In order to do that, you need the angle it makes with the x-axis. Right? Similarly, you need the angle of this vector that it makes with the x-axis. That will be that angle. Alright, so our next task is to find the angle F32 and F31 makes with the x-axis. So watch this again. The angle F31 makes with the x-axis, this is the x-axis, will be that angle. That will be a negative angle. The angle F32 makes with the x-axis will be that angle. Is that right? Okay, that's the net force on Q3 is the resultant of these two forces. And to write them in the component form, we need the angle they make with the x-axis. So that's our next task, to find those angles. Now I have made the diagram now look big. I want to now find the angles these two vectors make with the x-axis. I know the magnitude of F31 equal to the magnitude of F32 equal to 0.0012. If theta is the angle F32 makes with the x-axis, well, let's first go for this angle. If theta is the angle F32 makes with the negative x-axis, well, finally this is not the angle we want. But once you know this angle, you can add 180 to that to get the actual angle. So let's find that angle. Can you help me find that angle? This is an acute angle in this right triangle. Is that right? For this angle theta, the opposite side is 3 meters. The adjacent side is 8 meters. Therefore, I can say tangent of angle theta is 3 divided by 8. So tangent of angle theta is 3 divided by 8. And now you've got to go to your calculator and find theta. What is theta equal to? Theta is tan inverse of 3 over 8. I hope everybody is familiar with this. If tan theta equal to 3/8, then theta is tan inverse of 3/8. So go to your calculator, make sure that your calculator is in degree mode. Keep it in degrees so that we can find the answer in degrees. And then type this in, tan inverse. Well, you should know how to get the keys for tan inverse. Tan inverse of 3/8, and that should give you 20.6 degrees. So this angle is 20.6 degrees. Therefore, the angle F32 makes with the positive x-axis will be 20.6 plus 180 degrees. Now, can you tell me, what is the angle made by F31 with the x-axis? If you know by symmetry, this angle theta is the same as this angle. Is that right? Because this angle is opposite to that angle. And this angle are equal because the sides are equal. So this angle, the angle F31 makes with the x-axis will be negative 20.6. Is measured from the x-axis downward. That angle is negative. The angle measured from the x-axis counterclockwise is positive. So the angle of F31 is now negative 20.6 degrees. That one is negative 20.6 degrees. And the angle of F32 is 20.6 plus 180 equal to 200.6 degrees. Okay, I hope you understood that. One more time, we now know that the angle F31 makes with the x-axis is negative 20.6 degrees, and the angle F32 makes with the positive x-axis is 20.6 plus 180, which is 200.6 degrees. There you are. So you got the two angles. We can now write these two vectors in the component form. Let's do that in here. So we have F31, you can see the value of F31 is 0.0012 Newton. So this F31 is now 0.00121 cosine of this angle I, that's the x component, plus 0.0012 sine of that angle, that will be the y component. Now, you need to put that in your calculator, but make sure that your calculator is in degree mode. Now, that will be 0.0011 Newton I, that is the x component, that way, and minus 0.0042 Newton J, the y component. There. This is the x component. That is 0.0011 Newton. And this is the y component. Remember, the y component can be drawn here or here. Is that right? Makes no difference. This is the y component, that is negative 0.0042 Newton. So we have now obtained the x and y components of this. Similarly, let's write this vector as the sum of its x and y components. I'm sure you can do that. F32 equal to, again, the magnitude of this is 0.0012. So that will be 0.0012 cos of angle 200.6 degrees I plus 0.0012 sine 200.6 J, the x component plus the y component. And now when you put that in your calculator, it will give you, this quantity is negative 0.001 Newton I. Put that in your calculator and see whether you get that negative value. This also is negative. Put that in your calculator and see whether you see this. minus 0.00042. Alright, let's mark that over there. This is the x component, that is negative 0.0011 Newton. And this is the y component, which is that negative 0.00042 Newton. Now, you notice one thing. The force on this Q3 in the x direction, there is a positive x component 0.001 Newton and a negative component 0.001 Newton. That positive value and that negative value, they cancel each other. Is that right? One is equal and opposite to the other. So these two values will cancel and these two will add up. So F net, the net force on Q3 is F31 added to F32, which is, you now add the components. That is, these two will now, the I components, that is 0.0011 Newton I added to negative 0.0011 Newton I. So the terms containing I will cancel and the terms containing J will add up to give you this. This is the net force on Q3. That has been a good problem. I'd like you to learn how to do these kind of problems. Let's do another one. 3 charges, each of magnitude 3 nanocoulomb, are at separate corners of a square of side 5 centimeter. The 2 charges at the opposite corners are positive and the other charge is negative. Find the force exerted by these charges on a 4th charge, Q4, equal to 3 nanocoulomb at the remaining corner. Alright, I would like you to take a couple of minutes and read this one more time and draw that picture showing where the charges are and what is the force that we are required to find. Alright, take a moment and do that. It's very important to have that ability to do this. Well, this is the picture I have produced. 3 charges, each of magnitude 3 nanocoulomb. Each of the charges placed at the 4 corners of a square. The side of the square is 5 centimeter. Each of this is 5 centimeter or it is 0.05 meter. Now, what does it say again? The 2 charges at the opposite corners are positive. So Q1 is positive, Q3 is positive, and the other charge is negative. That is this Q2. Q2 is negative. Now, we need to find the force exerted by these 3 charges on a 4th charge Q4, which is a positive 3 nanocoulomb. So identify Q1 is positive, Q3 is positive, Q4 is positive, only Q2 is negative. Alright, before we move from this slide on, the first thing to figure out is what are the distances involved. We are looking for the force on Q4 by each of these. So, tell me, what is the distance of Q4 from Q1? We call it R14. Is the length of the side of the square, which is 0.05 meter. Similarly, the distance of Q3 from Q4 is R34, also is 0.05 meter. But what is the distance of Q2 from Q4? It is the length of this diagonal, and you can see that diagonal is the hypotenuse of this right triangle, where each leg is 0.05. Is that right? So I can write R24 squared, the square of these distance, is 0.05 squared the square of this distance plus the square of this distance. Is that right? Yes. Now do that on a piece of paper and use your calculator and see whether you come to this answer. R24 squared is 0.05 squared plus 0.05 squared. Do you get that answer? Alright, I'm going to leave it for you to check. So now we know all these distances. Let's find the force on Q4 by Q1, the force on Q4 by Q3, and the force on Q4 by Q2. Alright, let's do that in the next slide. Now, there is my picture. F41, what does F41 stands for? Force on charge 4 by charge 1 is K Q1 Q4 divided by R14 squared. I just used the values there. K is 9 times 10 to the 9. Q1 is 3 nanocoulomb, 3 times 10 to the negative 9. And Q4 is also 3 nanocoulomb. And R14 is 0.05, and therefore the square of that. And that is 3.24 times 10 to the negative 5 Newton I. Now, how did I arrive at that? What I said here is that F41 is this much force in the positive x direction. This is positive x direction. Is that true? Q1 is a positive charge. Q4 is a positive charge. Therefore, the force on Q4 by Q1 will be directed away from it, directed towards the positive x-axis. So that's the direction of F41. 3.24 times 10 to the negative 5 Newton I is F41. F43, if you notice, the force on charge 4 by charge 3 is a similar quantity. All these numbers are the same. K, Q3 is 3 nanocoulomb. Q4 is 3 nanocoulomb. Divided by R34 squared is the same number. And so that will be negative 3.24 times 10 to the negative 5 Newton J. Where did I get that negative sign from? Well, I got the negative sign by this argument. Q3 is a positive charge. Q4 is a positive charge. Therefore, the force on Q4 by Q3 is a repulsive force. It will be directed away from Q3. It will be directed in the negative y direction. You see that? And that's where I got these two. The force on Q4 by Q3 is a negative y force. It's equal to 3.24 times 10 to the negative 5 in the negative y direction. So, we got two forces, F41 and F43. We need to find one more force. And that is, what is F42? Can you help me with this? F42 is K Q2 Q4 over R24 squared. Is that right? And now, K is 9 times 10 to the 9. Q2 is negative, but we will only use the positive value for the calculation. That is Q2, that is Q4, and this is the square of the distance between them. Now, what does that equal to? That will be 1.62 times 10 to the negative 5 Newton. And you can see I haven't used any I or J there because I don't know in what direction it is exactly. Do I? But do you know? How do we know? What is the direction of the force F42? Well, Q2 is a negative charge. Q4 is a positive charge. That means the force on Q4 is an attractive force. Q4 is pulled towards Q2. So the direction of this force F42 will be directed towards Q2. This force is directed well, this is not quite right. So this force is directed towards Q2. There you are. It's directed towards Q2. Now, can you find the angle this force, that is F42? Can you find the angle F42 makes with the x-axis? You don't really need to do any calculations. By looking at the symmetry of the diagram, you can tell me that angle. Why? Because if you see, this is a square, and this is the diagonal of the square. That means this right angle, I hope you're following this right angle is divided exactly into half by the diagonal. That means what is this angle? That angle is 45 degrees. And this angle is 90 degrees. The angle F42 makes with the positive x-axis is therefore 90 degrees plus 45 degrees is 135 degrees. Well, the forces F41 and F43 are in the proper x and y directions. We don't need to do anything with it. F41 is a proper x force. F43 is a proper y force. So we need only break F42 now into x component and y component. Well, we now know that the angle made by F42 is this 90 plus 45 is 135 degrees. There you are. So that angle is 135 degrees. Can you now write F42 as the sum of its x component and y component? Alright, I'm going to do that. F42 written in the component form will be, I'll give you a last chance. Think about it. It will be the magnitude of it. What is the magnitude of that force? I forgot. The magnitude was 1.62 times 10 to the negative 5. So that's the magnitude. That is 1.62 times 10 to the negative 5 cos 135I. That is the x component. So you can see that's going to be a negative number. If you put this in your calculator, it will give you a negative number. So that's the x component plus 1.62 times 10 to the negative 5 sine 135 degrees J. Alright, put that in your calculator and see whether you get this. The x component is negative. Negative 1.15 times 10 to the negative 5I plus 1.15 times 10 to the negative 5J. In other words, it has the x component that is negative and the y component that is positive. Well, let's now write all these together. F41 is 3.24 times 10 to the negative 5 Newton I. It's an x force. F43 is negative 3.24 times 10 to the negative 5 Newton J. So the F41 is an x force, F43 is a y force, and F42 has an x component and a y component. So when you add all the three, our usual way is add the x component, so you can add the x's and then add the y's. Alright, so F41 plus F42 plus F43, the sum of these three will be, add the i's. See what I have done? It'll be 3.24 times 10 to the negative 5 Newton I minus 1.15 times 10 to the negative 5I. I put the i's together, it's easy to add them. plus, now add the j's, the y components. It will be 1.15 times 10 to the negative 5 minus 3.24 times 10 to the negative 5j. There. This is the net x component and this is the net y component. And now use the calculator. You've got to be busy when you do problems like this. What does that give you? That gives me 2.09 times 10 to the negative 5 Newton I. That is the net x component. And what does that equal to? Minus 2.09 times 10 to the negative 5 Newton J. So the net force on this charge has this x component and this y component. Well, once you know the x and y components, can you find the resultant of that? Well, let's go over there. Let me take you to my whiteboard. Now, suppose this is the x force and this is the y force. The resultant of those two will be that. I hope you recognize this. We discussed all this in Physics 1. If this is the x component, which is that value, and this is the y component, which is that value, the resultant vector will be that. And the length of that will be square of this x squared plus y squared. And so the length of that will be square root of x squared plus y squared. And how do you find the angle of this vector? Now remember, angle of a vector is the angle it makes with the x-axis. Well, if this is the angle, then you have your y and your x. Now what I have written y here is the y component. But actually it has to be negative. Is that right? Let me draw the x component is positive, y component is negative. Therefore that is our resultant force there. This is x, this is y. We are looking for that angle. So I don't want you to look at that diagram. Here our x is positive, our y is negative. Therefore this is the resultant force. The magnitude of that resultant force will be obtained by finding the length of the hypotenuse. Square root of x squared plus y squared. And the angle theta is obtained by how? Tangent of that angle theta is opposite side divided by the adjacent side, y over x. And hence we can find the angle. Alright, let's do that now for this. So this is the x component, 2.09 times 10 to the negative 5. This is the y component. Alright. The magnitude of this force is square root of x squared plus y squared. That is 2.69 times 10 to the negative 5 Newton. That is the magnitude of the resultant. And the angle theta is given by tan inverse of y over x. This is the y, this is the x. And that angle is this, which is negative 45 degrees. It's a fourth quadrant angle. So we found the magnitude and direction of the resultant. A very important method of solving problems like this. Alright? I would like you to do these kind of problems. I have actually one more problem, but I would like you to leave it for you. Look at that problem on your own. But in the meantime, concentrate on the 3 problems that we did. And example 6, I'm going to leave it. You can look at the printed version of that and see whether you can figure it out. If you have difficulty, just leave that. If you know the first 3 types of problems, You should be fine. All right? Okay, I'm going to stop this lesson here. I'm going to come back to you with lesson 3.2 later on. All right? In the meantime, go back and do some of these problems and do all the homework. And always remember to get back to me when you are in trouble. Okay?